Have you ever wondered, what if you could travel back in time and change something? Let's pause for a moment and think about time. What is it exactly? A ticking clock, the change of seasons, or our aging bodies? These are all evidence of time's relentless march forward. But is that all there is to it? In our daily lives, time governs everything. We wake up, eat, work, rest, all according to the seemingly predetermined rhythm of the 24-hour day. But is time really as straightforward as it appears? Or is there more to the story? Let's delve deeper. From a philosophical perspective, time has been a subject of great debate. Some argue that only the present exists, a fleeting moment that continually gives way to the future. The past, they say, is just a memory, a mental construct, and the future an anticipation. It's like we're standing on the edge of a precipice, with the past falling away behind us and the future stretching out unknown before us. Now let's shift gears and take a scientific perspective. According to the theory of relativity, time is not an absolute entity, but is relative and can be different for different observers. That's mind-boggling, isn't it? This suggests that our linear perception of time, with its neat division into past, present, and future, might just be an illusion. This illusion of time influences our perception of reality. We base our decisions on past experiences, live in the present, and plan for the future. Our entire lives are structured around this seemingly linear flow of time. But what if time isn't linear? What if it's more like a river, swirling and eddying, capable of looping back on itself? These questions lie at the heart of our understanding of time. They challenge our perceptions and force us to reconsider our place in the universe. Time, it seems, is more than just the ticking of a clock. It's an enigma, a mystery that continues to puzzle the greatest minds. Now imagine the possibilities if time was not as linear as we perceive it to be. Time paradoxes may sound like science fiction, but they are a fascinating concept to explore. Let's start with a simple analogy to understand what a time paradox is. Imagine you're reading a book. You start at the beginning, progress through the middle, and reach the end. This linear progression is how we typically perceive time. But what if you could flip back and forth between the pages of your life story, disrupting the natural order of events? This is where we encounter the concept of a time paradox. Now let's delve into two of the most well-known types of time paradoxes: the grandfather paradox and the bootstrap paradox. The grandfather paradox is a hypothetical situation that goes something like this. Suppose you had a time machine and you used it to travel back in time to a point where your grandfather was a young man, long before your parents were born. Now, if you were to somehow prevent your grandfather from meeting your grandmother, it would result in one of your parents never being born, and hence, you would not exist. But if you don't exist, how could you have traveled back in time to prevent your grandparents from meeting in the first place? This paradox poses a contradiction and challenges our traditional understanding of cause and effect. On the other hand, we have the bootstrap paradox, named after the phrase, pulling oneself up by one's bootstraps. This paradox deals with objects or information that seem to exist without any discernible origin. Let's illustrate this with a thought experiment. Suppose you're a scientist who receives a detailed blueprint for a groundbreaking invention from your future self. You build the invention, and it changes the world. Years later, you send the same blueprint back in time to your younger self. The paradox here is, who truly invented this device? It seems to have no original creator, as it's caught in an infinite loop of cause and effect. These paradoxes are more than just intriguing thought experiments. They challenge our perception of time as a linear, one-way street. They ask us to consider the possibility of a universe where time is more flexible, where cause and effect can loop back on themselves, and where the past, present, and future are not as distinct as we might think. Understanding these paradoxes challenges our conventional view of time and opens our mind to new possibilities. Imagine you have a time machine and you decide to travel back in time to meet your grandfather. Now we're entering the realm of one of the most famous time travel conundrums, known as the grandfather paradox. The paradox poses a simple yet mind-boggling question. What would happen if you used your time machine to go back and prevent your grandfather from meeting your grandmother before they had any children? If successful, one of those unborn children would have been your parent. This means you would never have been born, and therefore you couldn't have traveled back in time in the first place. A perfect circle of bewildering contradiction, isn't it? This is the grandfather paradox in a nutshell, a stark contradiction that arises from the idea of changing the past. It's a problem that has given theoretical physicists and philosophers quite a headache. The paradox suggests that any action that would cause a person to prevent their own birth would create a sequence of events that results in a temporal causality loop. Simply put, it's a situation where cause and effect endlessly feed into each other, creating an infinite loop with no beginning or end. But wait, there's more. The implications of this paradox are far-reaching, challenging our understanding of reality and the very nature of time itself. If the past can be changed, then the unchangeable linear view of time we hold could be fundamentally flawed. It implies that time, instead of being a straight line from the past to the future, might be a more complex structure, perhaps even a web of alternative histories and futures. The grandfather paradox forces us to question the logic of our universe. If time travel to the past is possible, then why haven't we seen any time travelers? Maybe it's because the universe has a way to avoid such paradoxes, a concept known as the Novikov self-consistency principle. Or perhaps time travel to the past is simply impossible. This paradox presents a contradiction that is yet to be resolved in the realm of theoretical physics. So, as we journey further into the mystery of time, let's keep our minds open to the unimaginable. Now let's delve into the Bootstrap Paradox, another intriguing aspect of time travel. Imagine this. You're a time traveler and you decide to take a trip to the past. You bring with you a book, a classic novel that you've cherished since childhood. You meet the author of that book before they even begin writing it. You leave your copy with them and they, inspired by your copy, write the exact same book. They publish it, and many years later, you buy that very book and eventually take it back to the author. So here's the question. Who wrote the book? This is a simple example of the Bootstrap Paradox, a concept that defies our understanding of cause and effect. It involves an item or piece of information sent back in time, which becomes trapped within an infinite cause-effect loop. The object or information has no discernible point of creation, it just exists, bootstrapping itself into existence. The term bootstrap comes from the phrase, pulling yourself up by your bootstraps, which signifies a self-initiating process that is supposed to proceed without external input. But in the context of time travel, the Bootstrap Paradox creates a circularity problem where cause and effect become indistinguishable. Consider this. If the book in our example was never written by the author, but instead was brought from the future, then its existence is a paradox. It exists, yet it was never created. It's a loop with no origin, no end, and no explanation. The Bootstrap Paradox challenges our linear perception of time and causality. It toys with the idea that the future can affect the past, and vice versa. It creates a chicken and egg situation where it's impossible to tell which came first. Yet, despite its complexity, the Bootstrap Paradox isn't just a mental exercise, it's a concept that pushes the boundaries of our understanding, prompting us to question the nature of time, causality, and the universe itself. The Bootstrap Paradox presents a circularity problem that adds to the mystery of time. Time paradoxes are not just a topic of scientific debate but also a popular theme in movies and literature. From the pages of a gripping novel to the silver screen, time paradoxes have found their way into the heart of popular culture. They create fascinating narratives that challenge our understanding of reality, making us question the very fabric of time itself. Take, for example, the iconic movie franchise, Back to the Future. Here, the concept of a time paradox is on full display as we follow Marty McFly and Doc Brown on their time-traveling escapades. The series is particularly known for its depiction of the grandfather paradox, where Marty almost erases his own existence by interfering with his parents' meeting. This film not only popularized the DeLorean car, but also the idea of time paradoxes, making us ponder what would happen if we could change our past. Then there's the film Predestination, which takes the Bootstrap Paradox to a whole new level. This mind-bending movie revolves around a time-traveling agent who becomes entangled in a series of events that he himself sets into motion. Here, the Bootstrap Paradox is the core of the narrative, demonstrating how an item or information can exist without any discernible point of origin, given that it is continuously looped within time. On the small screen, the British TV series Doctor Who has been dabbling with time paradoxes for decades. Known for its wibbly-wobbly, timey-wimey stuff, the show often features the Doctor and his companions altering timelines and dealing with the consequences of their actions. Whether it's meeting famous historical figures before they've made their mark, or the Doctor encountering versions of himself from different points in time, the series is a playful exploration of time paradoxes. In literature, we can look at the novel Time and Again by Jack Finney. It's a captivating tale of time travel where the protagonist alters history, only to find himself in a drastically different present. The paradox here is a powerful reminder of the potential consequences of meddling with time. From H.G. Wells' The Time Machine to the more recent Harry Potter and the Prisoner of Azkaban, time paradoxes have been used as compelling plot devices to create suspense, drama, and intrigue. These examples from popular culture highlight how time paradoxes have transcended the realm of scientific theory to become a staple in our entertainment. They allow us to explore the what-ifs of time travel, and in doing so they spark our imagination and fuel our fascination with the mysteries of time. In their own unique way, each of these stories underscores the mind-bending nature of time paradoxes. They challenge our perception of time and reality, and encourage us to question the rules we take for granted. These stories often use time paradoxes as plot devices, further sparking our fascination with the concept. While time paradoxes pose a problem, theorists have proposed some solutions. One of the most intriguing solutions to the time paradox is the concept of the multiverse. If we think of our universe as a singular, unique entity, then paradoxes become a serious issue. But what if our universe is just one of many? The multiverse theory suggests that our universe is just one of an infinite number of universes, each with its own unique set of laws and conditions. When a time traveler changes something in the past, they're not altering their own universe but creating a new one. This new universe splits off from the original timeline, forming a parallel universe where the time traveler's changes have taken effect. In this way, the original timeline remains unaltered and paradoxes are averted. The time traveler simply steps into a different universe, leaving their own timeline untouched. Now let's consider another theoretical solution, the Novikov self-consistency principle. Named after Russian physicist Igor Dmitrievich Novikov, this principle asserts that if an event could cause a paradox, the probability of that event happening is zero. It's a fancy way of saying that nature won't allow paradoxes to occur. Under the Novikov self-consistency principle, any action taken by a time traveler or any event that would cause a change in the past has already been accounted for in the flow of time. The future is just the past waiting to happen, and the past is the future that has already happened. They exist together, in a constant self-consistent loop. For instance, if a time traveler attempts to alter a past event, they will inevitably fail because their failure is what ensures the timeline remains consistent. It's like trying to change the lyrics of a song while it's playing. The song remains the same because it's already been recorded. The multiverse theory and the Novikov self-consistency principle are but two of the many theoretical solutions proposed to resolve time paradoxes. There are others such as the quantum superposition principle and the many worlds interpretation, each with their own unique take on the issue. However, it's important to remember that these are just theories. They propose interesting perspectives on how time paradoxes could be resolved, but they're still unproven. We don't have any empirical evidence to support them, and we may never have. Yet the beauty of theoretical physics lies in its ability to push the boundaries of our understanding, to challenge our assumptions and make us think in new ways. Even if we never confirm these theories, they still serve a valuable purpose. They make us question, they make us wonder, and they make us strive for a deeper understanding of the universe and our place in it. These theories, while unproven, offer interesting perspectives on how time paradoxes could be resolved. So, can we really travel through time? The short answer is, we're not sure. The long answer, well, that's a bit more complex. Time travel, as we understand it today, is largely theoretical. We've yet to invent a machine that can transport a person back to the days of the dinosaurs, or forward to the futuristic cities of the 22nd century. But that doesn't mean time travel is entirely off the table. In fact, Einstein's theory of relativity suggests that time travel might be possible, at least in one direction. This theory explains that time and space are interconnected in a four-dimensional fabric known as spacetime. And this spacetime isn't rigid. It can be bent and warped by mass and energy. This warping is what we experience as gravity. Now here's where time travel comes into play. According to Einstein, the stronger the gravitational field, the slower time passes. This phenomenon, known as time dilation, has been experimentally confirmed. Astronauts aboard the International Space Station, for instance, age slightly slower than people on Earth due to the weaker gravity. But the effect is minuscule, far from the dramatic time leaps depicted in science fiction. Speed also plays a role in time dilation. The faster you move, the slower time appears to pass. If you could somehow travel at the speed of light, time would theoretically stop completely. But that's a big if. According to our current understanding of physics, accelerating an object with mass to the speed of light would require infinite energy, a hurdle we're nowhere near overcoming. So where does this leave us with time travel? Well, it seems we're still quite a way off from hopping into a time machine and visiting our past or future selves. But the scientific foundations are there, and the concept continues to captivate scientists and dreamers alike. While time travel remains a fascinating concept, its realization is a question that science has yet to answer. The concept of time continues to baffle us, from its unyielding forward march to the paradoxes it presents. This relentless flow, always moving forward, never backward, is a constant in our lives. Yet the more we delve into its depths, the more we realize that time is not as straightforward as our everyday experiences would suggest. Our journey today has taken us through an exploration of the paradoxes of time, from the mind-boggling grandfather paradox to the intriguing Bootstrap Paradox. We've dipped our toes into the theoretical solutions proposed by brilliant minds to reconcile these paradoxes, and even touched upon the portrayal of time paradoxes in popular culture. Time is something we are all familiar with, yet it is also one of the most elusive and intangible concepts we grapple with. It is omnipresent yet invisible. It is measurable yet abstract. It is unyielding yet malleable in the realm of theoretical physics. This duality, this paradoxical nature, is part of what makes time such a captivating mystery. It is also a reminder of how much we still have to learn about the universe. As we've seen, time is not just a simple ticking clock, but a complex and intricate part of our reality. It challenges our perception of what is possible, stretching our understanding and forcing us to question our assumptions. In the end, the mystery of time is a testament to the beauty of the unknown. It serves as a reminder that there is always more to learn, to explore, to unravel. It's a humbling thought, but also an exciting one. The enigma of time is a puzzle that we have yet to solve, an adventure that we are all a part of. As we continue to explore the enigma of time, we are reminded of the vastness of the universe and the mysteries it holds. The journey is long and the road is winding, but the promise of discovery and understanding makes the journey worth it. Our exploration of time is just beginning, and who knows what extraordinary revelations the future may hold. Thank you for joining us on this fascinating journey through the enigma of time. We've delved into paradoxes that have puzzled the greatest minds, simplified complex concepts, and even explored time in the realm of popular culture. From the grandfather paradox to the bootstrap paradox and theoretical solutions, we've navigated the intricate maze of time's mysteries. However, as we have seen, time is not merely a ticking clock, but an intricate part of our reality that challenges our perceptions and assumptions. It's a humbling yet exciting thought, this reminder that there is always more to learn, explore, and unravel. The enigma of time is a testament to the beauty of the unknown, a puzzle we are all part of solving. We hope this journey has sparked your curiosity and inspired you to delve deeper into the mysteries of time and its paradoxes. After all, the promise of discovery and understanding makes the journey worth it. As we've seen, time is not just a simple ticking clock, but a complex and intricate part of our reality. It is a reminder of the vastness of the universe and the mysteries it holds. Thank you for watching, and we hope you'll join us again as we continue to explore the fascinating world of time, space, and beyond. Remember, our journey through the enigma of time is just beginning. Who knows what extraordinary revelations the future may hold?